Ladies and gentlemen, good afternoon. My name is Valeri Souchkov, and I'm going to present a paper or a presentation on the topic Business Trees to Overcome VUCA Challenges. I would like to thank the organizers of TRIZ 4X 2022 conference for having me here, and I wish you to have a great conference. Okay, let's start. I'm a TRIZ master and I represent three organizations. One is ICG Training and Consulting. It's a training consulting company located here in the Netherlands. Second, I'm a vice president and board member of TRIZ Official, an association which promotes TRIZ all around the world and certifies TRIZ practitioners and experts and masters. And IBTA, it's International Business TRIZ Association, which started very recently, just 2 years ago, but quickly gains popularity. Okay, so my task is to talk how business TRIZ helps to deal with volatility, uncertainty, complexity, and ambiguity. And I'm not going to talk about technical TRIZ. I'm going to talk about business TRIZ. And what is business TRIZ? Perhaps you know that TRIZ was founded back in 1956. At least the first journal paper appeared at that time. Was written by Genrich Altschuler and Shapiro, two authors, and it was first published in the magazine Questions of Psychology. And well, since that moment, we give a start to TRIZ. TRIZ was supposed to help engineers with technical invention or innovation. But of course, it was mostly focused on front end of innovation and dealt with technical invention. However, later, during its evolution, some branches were created along the evolution of TRIZ. TRIZ still today evolving. It's a big discipline which presents quite a large body of knowledge devoted to technical inventions and innovations, and you see it's still evolving. However, there were several branches which emerged at certain times, like a theory of creative personality development, TRIZ pedagogy, OTSM TRIZ, theory of powerful thinking, is the main independent TRIZ. It is application of TRIZ way of thinking in regular life. TRIZ for non-technical areas, in 1984, first paper was published, and in 2001, TRIZ for business and management emerged, which today we call business TRIZ. Business TRIZ is very similar to technical TRIZ. If technical TRIZ helps to develop technical inventions, then business TRIZ helps to develop business inventions. Also, there is a difference between technical inventions because they can be patented. Business inventions cannot be patented, but what is business invention? Business invention surrounds us everywhere. Business invention is about developing new business models. Business invention about developing new business systems. Business invention is about developing new services, which are products of these business systems. And if you look at the modern countries, today almost 70% of their GDPs is formed by non-technical but service innovations or services. Not every service was innovation at once, but today we are surrounded by huge number of business services. So the business trees is going to be a very powerful method to help to create business inventions and innovations, of course. So let us have a look. What are the core advantages of trees? When you hear about trees the first time, then most of sources say that the major core advantage of trees that you can create great ideas. Well, you know that human civilization and technology was evolving without trees, and a lot of great and breakthrough ideas were found without trees. So trees is probably great for finding great ideas, but I would put, as follows from my 30 years of experience with trees, the first core advantage is that trees accelerates time to search for an implementable solution dozens of times. Yes, it is true. The first and core advantage of trees is that it accelerates search for a needed solution. Second core advantage is that trees helps to find solutions close to ideal. Those of you who know trees, who learned about basics of trees, you definitely know about ideality, ideal final result, ideal solution. And trees does not only help you to find a breakthrough idea, but it helps you to find a number of ideas, and some ideas will be close to ideal. Ideality means the maximum benefits at lower costs. What is so important about ideal solutions? Because you probably know that only 2% of patented ideas have been implemented or were implemented. And the failure rate of R&D innovative process is 95%. And why is it so? Of course, because we cannot find ideas in some situations. But in some situations we find ideas, they solve the problems, but they are too expensive to be implemented. So the ideal solution means that the solution can be easily implemented without much costs. So I consider it as a second great trees core advantage. The third core advantage of trees is that trees brings laws, trends, and lines of utilitarian systems evolution, knowledge of which drastically reduces risk of wrong investments. Utilitarian systems, I mean systems which deliver a certain utilitarian function, which helps our lives. I'm talking about technical functions, I'm talking about business functions, and so on. And the first core advantage of trees is that while practicing trees, you really develop your personal creative thinking skills. So these are core advantages of trees, which are very valuable for dealing with VUCA world. Today, trees, business trees, consist of three large areas. First area, it is solving specific business problems and challenges. It focuses on solving a particular problem. Second part of business trees is about improving the existing systems and services. We discover innovative potential of our systems and services, existing systems, services, and improve it. Or we can radically or disruptively cut costs for existing business processes and business systems and business services. Disruptive cost reduction means that you do not really evolve performance or some other characteristics of your process, but you drastically cut costs to deliver this process. And the third area of business trees is about future. about future forecasting and road mapping, generating radically new and disruptive business models and products. With products, I mean services. So these three large areas of TRIZ have a corresponding sets of tools which help to deliver projects in each area. Once you learn TRIZ, you develop your competence across all three areas. Well, I will not focus on the process, on the tools right now and description of them, but I would like to show how these parts of TRIZ can help you to deal with VUCA world. We start with volatility. What is volatility? Volatility means ability to change rapidly and unpredictably to adapt as a response to changing environment. And you know that the speed of changes accelerates. Well, that's very simple. If 50 years ago you could invent some technical solution or technical innovation, you could patent it and then relax for at least 20 years. And you know that today's situation is completely different. We are out of this industrial age. If you develop and patent something, that you can be sure that your competitor in 2 years will come up with a better solution and more sellable solution. So you cannot wait for 20 years. You can wait maybe for 2 years, even if your solution is patented. That's what forces us to accelerate our time for adaptation to the ever-changing world, and a world which changes much faster than 40-50 years ago. And as you probably know, there are two types of problems which have to be solved to adapt and change. First type of problems are called closed problems. Closed problem means that there is a finite number of solutions to a problem, and these solutions can be found with certain formal methods. The best way, the best example of such problems are optimization problems. If you know all variables, you can easily calculate an optimal structure, an optimal solution. But the worst type of problems are so-called open-ended problems. Open-ended problem is a problem which has infinite number of solutions. At this picture, I showed an example of ideas generation session of a friend of mine, Gijs van Wolfen, who is author of Fourth Method of Innovation, very famous, translated to most of languages in the world. It is a picture from his session. They generated 1,093 solution ideas to one problem. Open-ended problems are different from closed problems because they do not have formal methods for obtaining solutions. And a problem with open-ended problems. Well, I can give you an example of an open-ended problem. You see, I have a vessel with water, a bottle with water, and I set up a problem. I put it on a table and ask a question. How to remove water from the bottle without touching the bottle? Okay, I can give you some moments to think about, but I can tell you. First of all, you can remove it with a straw, or you can remove it by heating the bottle, and the water will evaporate, and so forth. You know, how many solutions exist to this problem? Well, once we did an experiment and we generated about 150 solutions how you can remove water from the bottle without touching the bottle. But how do you solve open-ended problems? Today there is only one way. Before TRIZ, there was only one way to solve them, with the help of brainstorm. There are, at this moment, approximately 110 different ways of brainstorm. It's a lot. Some are better, some are worse, but there are still a brainstorm based on trials and errors. And in one of his earliest works, Gerhard Schuler, the founder of TRIZ, described a number of trials which you need to solve problems of different complexity. For simple problems, from 1 to 10 trials are enough. From more difficult problems, you need to do 100 and 1,000 trials. But for most difficult problems, you need to do 10,000 trials, which means lots of wasted time, effort, and human labor. Sometimes, there are problems which cannot be solved for dozens of years. And I'm talking about open-ended problems. What is the advantage of TRIZ? TRIZ provides you with analytical tools and problem-solving tools. And problem-solving tools are described as principles and heuristics, which drastically shorten time to the needed solution. And the advantage of TRIZ versus other methods is that TRIZ helps you to find a pragmatic solutions. Not fantastic, not science fiction, not fantasy solutions, but really pragmatic solutions. Because TRIZ is based on the experience and knowledge of many generations of inventors. One friend of mine, he's about 80 right now, he used TRIZ in his area. And currently he has more than 800 patents. 800 patents he generated alone during his life. Could he do it without TRIZ? No, definitely not. I personally consider volatility-related problems as a biggest challenge where TRIZ can help. Let me give you a few examples. All examples are from my practice, and solutions were found by our team. So, problem number one. You remember, very, very recently, there was a pandemic, COVID-19 pandemic, which brought lots of measures in different countries to protect their population. One of my customers, a company which repairs a second-hand food manufacturing equipment. And when the COVID pandemic really started, the city where the company operated introduced blocking measures. The people, the companies were not allowed to visit their customers. Only a number of companies involved to specific businesses, like hospitals, for example, or emergency services, were allowed to visit their clients. Of course, nobody knew for how long this would last. And the city made a list of businesses which are allowed to visit their customers. And my customer company, was not in the list because they were not given the code to visit their customers. Because they were repairing second-hand equipment. But the companies who were repairing the original equipment, who were on a service level agreements, were allowed to visit their customers. But my company, which was about 50 persons at that time, didn't have the chance. They decided to wait. They waited for 6 weeks, and they had a financial cushion for around 4 weeks more. But then the money would be gone, and there were no way to take a loan. So the owner of this company contacted me. He knew me for a while and asked what to do. Well, we defined it as a problem and started to solve this problem. And of course, if you are a TRIZ person, you know that first you formulate a contradiction. The company must visit the customers to repair the equipment and must not visit their customer to obey the rules. Well, the contradiction was solved in 1 hour. And a solution to contradiction was, the problem-solving idea was to find an X component which will allow the company specialists to visit their customers. You probably know about the X component. And the contradiction was solved by the principle of merging. A company was quickly sold to another company which was allow it to visit their customers. So we quickly found a company which was repairing original equipment and proposed them to hire our specialists. They did it instantly because, they were not financially risky. No financial risk because our company had a pool of customers and there was no financial risk. So you see, TRIZ saved the whole company within 1 hour. 1 hour it was time to find the solution. What this example shows? The company was absolutely not prepared for a changed environment. An environment was changing overnight. So the whole company with a business, they did this business for years by this moment, was completely out of business. And they didn't know what to do. They decided to wait. Well, but waiting for 6 weeks didn't help. Nobody knew how many weeks they would have to wait. So the TRIZ helped to find a solution which completely adapted a company, or at least their people, to this situation. A second example happened approximately, it was 17 years ago, in one European city, where the municipality suddenly decided to ban the outdoor advertisement along automotive roads. Well, you know what it means, that outdoor advertisement can distract the drivers and they can go to accidents. And my customer company was a company which was outdoor advertisement agency, which was placing all these advertisements along the streets. So they were also very emotionally tired because all this business would go bankrupt. And of course, there were a lot of agencies who did all other types of advertisements, but they didn't know how to do it because they could not compete with other agencies. Well, I told them, wait a second, and let's go TRIZ with that. So we formulate a contradiction. The advertisement has to be along the automotive roads and may not be along the automotive roads. So the advertisement has to be along the automotive roads and must not be along the automotive roads. Well, I'm sure you know the solution already, and it's been used for many, many years. But it was a different business model. So what we decided to do? Okay, what can be the source of advertisement? Which are resources would help us to stay alive? And again, to find an X component which will provide the advertisement on the roads without violating the law. And we used resource analysis, and we quickly found a solution. Other municipality transportation, like buses, trams, trolley buses. And the solution was to use other cars as carriers of advertisement. But you might tell me this solution was there long ago, even 100 years. at some cities, especially in America. I would say, yes, of course, it was there long ago, but there were no special company which was managing this advertisement. The advertisement dealt directly with bus companies, with transportation companies. And our company became the first agent to provide a connection between the transportation companies and advertisers. Again, this solution was implemented and saved the company from bankruptcy. Let's have a look at the next part of VUCA world, uncertainty. Uncertainty is the inability to know and predict everything due to non-linear character of evolution. You know, in TRIZ, we call it S-jumps. S-jumps which form different spirals of evolution. Well, actually TRIZ was the first scientific discipline, if I might say so, which established regularities of evolution of technical world. In TRIZ we found that no matter what area of technology an object belongs to, either it is microelectronics or optics or machines, they all evolve according to the same regularities and patterns. And since 1970s, TRIZ evolves largely two parts. First part is problem solving, and the second part is evolution of technical systems. We found that evolution of technical systems closely resembles evolution of business systems. It is not a coincidence, because a good business system is actually the same as machine. The parts of business system must work as the parts of a machine within their tolerances and deliver clearly defined functions. Of course, in human-based systems, in business systems, the psychology plays a central role. But psychology is manageable. Just like technical systems are based on physics, and the laws of physics are known and well used, in business systems we also know the interactions, we understand the communication factors, and we can manage a psychology. So the trends and laws of business systems evolution are very similar to trends and laws of technical systems. Such similarity helped it to develop the laws and trends of evolution for business systems. We have different parts of it, and one large part is formed by models of evolution. Models of evolution like the famous S-curve evolution, the lower known, the bell curve evolution, and there are other models. And all these lines correlate with each other. And once you identify at which stage of evolution you are, you can very reliably predict the other lines of evolution, models of evolution as well. So you know where you're going to move along each line of evolution. In addition, we have Moson-Soti trends and lines of evolution. They are more specific lines. There are more specific patterns. Like one of the patterns is a functionality evolution, the trend which consists of 18 steps of evolving functionality of systems. And of course, we know how systems are moving from one paradigm to another paradigm, where the main goal and main useful function of a system becomes provided by a different principle or a different business model. We call it S-jumps of evolution. and each jump creates its own S-curve. And each own S-curve is characterized by either emergence of a new main parameter value or radical change of an existing parameter value, which is not possible on the previous paradigm. So the shift of the paradigm is happening. And knowing all these trends, knowing all these laws, knowing all these models of evolution considerably helps to reduce uncertainty, what to expect in the future. One of the examples I want to show was done by one of the Dutch chains of supermarkets. The task was to roadmap future innovations in a supermarket chain. There are certain tools. I showed you previously the tools of TRIZ, and the whole third area actually helps to build such innovation roadmaps. So what we did, we applied a tool which is called value conflict mapping. It is just a small fragment of this table, but it consists of analysis which parts of a system are responsible for each market demand and market trend. For example, if you look at the supermarket, you definitely have a certain market demands, like it should be short working time, there must be no crowds, there must be broad selection of goods, all products must be fresh. You have to advise, you want to advise a quick professional, you want to get a quick professional advice from the personnel. You want to have a high quality of advice. You don't want to wait in lines. All products have to be always available, and so on and so on and so on. What is this table helps? It helps to identify values and build business demands and identify all the conflicts which are currently blocking the existing supermarkets from fully achieving that market demand. For example, if you want a quick advice from personnel, a number of personnel must be high, but to save in costs, the number of personnel must be low. The same is high quality of advice. A competence of the personnel must be high, so you get a high quality of advice, but the competence of the personnel must be low, because high competence personnel cost much more than low competence personnel. You see, once you made an analysis of such a system, then you can find all the contradictions which belong to the parts of the system, like shopping space, personal goods, and so on and so on and so on. And then what you do, you take the objects, we call them objects, which causes a most number of contradictions or conflicts. And we do not solve these conflicts, no. What we do, we look at the lines of evolution at this radar and identify how this part could be evolved further. Because each line shows evolution of a certain parameter from 0 to, let's say, 10. So we roughly split all these evolution lines to 10 steps, and each step show how the transition from one step to another was made in the past. And we take this pattern and apply it to our system. And you see that in our system, only 2 lines are evolved to 3 lines are evolved to their full extent. The other lines have a lot of potential to evolve. And we apply a new pattern and see, will it resolve most of contradictions? As usually, yes. So, as a result of this project, The project time was 1 month, and after 1 month, during 6 years, 14 solution ideas were implemented by the supermarket chain. So 20 ideas, solution ideas, are still to be implemented. So as a result, we found 35 ideas were selected. There were many more ideas, but we selected most potential, the ideas with most potential, 35 ideas. So what I want to say is that having a knowledge of universal patterns, laws, trends, and lines of evolution helps you to identify most probable ways of evolution of your system, or your product, or your service, whatever you want. And this knowledge greatly helps to avoid unnecessary investments or wrong investments, and to invest only to the directions which by statistics are most probable. And this greatly reduces uncertainty and improves the VUCA world. Next letter is complexity. Complexity means that too many parts of the world are interconnected and interdependent. And well, every 10 years we face a double or triple of even more times increase of complexity of our world. So if in the past we could have some central organization which could control everything, that today it's totally impossible. And also what makes it difficult to identify the interrelationships between all the parts. But TRIZ also helps with that. We have tools. We have tools, analytical tools, which help to focus on analysis of systems and problems. The famous function and cost analysis, or sometimes called just function analysis, helps to identify the core interactions between all the system's components, which are based on functions, defined on TRIZ definition of functions. For complex problems, we have a root conflict analysis. This is a typical example of a problem which involves 40 contradictions, 40 conflicts. Of course, this problem is very difficult to solve. Actually, this problem was made at Texas Instruments, you know, such company. And the problem was why TRIZ is not adapted by the company. And we found around 40 contradictions which block successful adaptation of TRIZ by Texas Instruments. So it shows that the problem is not an easy. It is a really complex problem. But the good way is that by providing this sort of analysis, we map all the causes and conflicts which prevent a problem from being solved. And another type of analysis is called flow analysis, because any process is a flow. And in particular, we deal with flows of information, material, and energy. So 3 types of flows. And we identify the stagnant points, we identify the waste points, and so on and so on and so on. Well, we can identify how the flow of matter or energy or information goes through the system, which also gives us a picture showing all the weak points in our system. And the last part, ambiguity. Ambiguity means that there can be many interpretations given to the same event or phenomenon. TRIZ is not very well deals with ambiguity. At least there are not many tools which help to deal with ambiguity. Ambiguity is more probably on a scientific level, should be solved on a different levels than TRIZ is at this moment, because ambiguity deals with recognition of situations, with given interpretations of different situations. But at least two tools there are in TRIZ. One tool is called perception mapping, or sometimes it's called problem perception mapping. It is collecting opinions of a stakeholder, of a stakeholders who are engaged into some problem or a situation, and who gives their opinions about situation. Then these opinions are structured in a causal way. What is a cause? What is an effect? And the opinion with most entrances to it will be a most shared opinion. And another tool which we used, it's a value mapping, which helps to identify what contributes to a value of a product or a service, and from which parameters of value this value consists of. And of course, the MPVs analysis, main parameters of value, also helps to identify what is really valuable in your system or a product and a service, which also reduces ambiguity. But I believe that tools which will help us with ambiguity, reducing the degree of ambiguity, will be developed better in TRIZ, or maybe not in TRIZ, maybe in some other disciplines, who knows. But still, there is a problem which has to be solved. So in my short overview, I tried to show you that actually many parts of TRIZ can help to deal with VUCA world. First, it is volatility. I believe that this TRIZ is mostly adapted to deal with volatility problems, where you have to find a solution to a very rapidly changing environment fast. You have no time to wait, because if you wait, you are dead. So TRIZ helps to find a solution much quicker than any other, to open-ended problem much quicker than any other method. Uncertainty, yes, the predicting the future. Well, the TRIZ has a big part for dealing with uncertainty. Because if we know the trends, laws, and lines of evolution, we can predict what will happen in the future. And since these patterns are universal, then the degree of probability grows. Dealing with complexity, we have tools which help us to decompose and understand the complexity of interrelated and interdependent parts in our systems. And finally, ambiguity. TRIZ doesn't help with that very much, but at least at some points it does. Okay, I think you were enjoying my presentation, and the last time I want to say, it's an old Chinese proverb. When a strong wind blows, some build up walls while others build windmills. You know, I live in the Netherlands, where windmills you can find at any place, but who knows for what was goal of these windmills. I'm sure not many of you know. So please Google it and find what was the goal of building so many windmills. One hint I can give you, they are all built along the rivers. Okay, ladies and gentlemen, thank you very much for your attention. And if you have questions, please, I will be happy to answer them. Thank you very much.